Hello everybody and welcome back. Today I thought we'd do something fun because the holiday season is almost over and I have some things left over. For example, I have one of these CNC control boards that I made myself. I've got a temperature sensor and I have a lot of these cheap geared steppers, and I thought we'd just combine all of this and make a small weather station. And I've already sat down and I made a few models for this. I started out by making the dials that the numbering's gonna be on. I made a small frame where we can fit everything, where the stepper just gets screwed in. And I 3D printed the parts that are needed to make the dials. And I have some carbon fiber tube from a kite set, and these fit in here, and they just snap in. And once they're snapped in, you've got a nice little dial, and we're going to make a little analog barometer with the barometric pressure, with a hygrometer and the temperature dial. And I've got the frame all made up. I have it fits the controller board really nice. It's not too big, so you can still put it somewhere where it looks nice. And as you can see, I used the laser cutter and just had everything laser cut. This is 3mm plywood, and the laser cutter that I have with the, I think it's a 2.5 watt laser, it works on this really nice. After that, I went ahead and I did the dials. I added the text for everything, and then I did a few pictures, and it looks really nice. And as you can see, this one didn't come out so well. It shifted during cutting, so it's a bit crusty and well done, but no worries. I made another one, and that one looks a lot better than this one. And once I'm done putting this together, it all just snaps together. Just it's press fit, no glue, no nothing. Just 6 screws holding it together and a bit of hot glue to hold down the board, and to fix down the wires from the steppers. And it's really simple. So that's a nice small project. But the first thing that we need to do is we need to convert this controller board, which is usually for 12 volts, to 5 volts only, and to use the USB supply so we can run it off a computer. And when we have that, we can just hook it up to a computer. It's going to work. We just have to make sure that we don't drive the steppers too hard, because they're 5 volts. They have a coil current of about 80 to 100 milliamps, and yeah, that is no issue at all. So 5 volts, 500 milliamps from a computer or a USB power supply is going to be enough to power this. So yeah, first of all, let's get rid of this 5 volt regulator. I'm going to remove it, and then I'm going to bridge pin 1 to pin 3, that is input to output, jumping over pin 2 and making sure that I don't touch it, because that would be ground. And yeah, we don't want to cause any short circuits. So let's just rip that one out. Here we go. That was easy enough. And now to just fit a wire bridge across that. Let's make this nice and clean. Let's make it just this is the simplest way of removing solder from a through hole. We add the bridge. And we solder it in place. And once again, we make sure that we don't have any short circuits. We have the nice wire loop. Pretty simple, but very effective. And what we now need to do, we need to leach the 5 volts to the secondary side or primary side of the regulator, because they're the same now. And I'm going to do this by just bridging the 5 volts from the Arduino to the 12 volts laser supply. That is a power rail, and that's all we need. So let's tin this just a little bit. There we go. And we wire this up. 5 volt is pin number 4. Is that true? 1, 2, 3, 4. So we got one bodge wire here, and we connect it to the old 12 volt rail, and we've got 5 volts where there used to be 12. So this now works as a USB powered Arduino and stepper controller. We're not going to use any other connections on this except for the I2C, and the I2C is made so it just accepts the BME 280 module, which is a combined sensor with humidity, temperature, and air pressure. And once we have that, basically this thing is done. All we need to do is get enough steppers and plug these in like so, and we'll be good to go. So let's remove the stepper I do have some M4 by 12 millimeter screws ready. Each stepper is inserted into the frame. We've got the thermometer on the far right. But actually it doesn't really matter, since you can just unplug and plug the stepper wherever you want it. But I'm going to put it to the far right. And we'll fix that one down lightly because we need to adjust this later. So we have the first one almost done, and it looks pretty nice. If you want to have a bit of distance between the dial and the frame, it would be possible to just put a washer between the two. That would make it a little bit more 3D. You can also see that there's a small index in here because the steppers don't have any position sensor. The steppers are just reset by moving backwards one revolution, and they will just run into the end stop, and they'll just keep on going until everything is done, and that will just put them to zero. They'll zero themselves that way. It's pretty simple. It's a little brute force, but it works. So we're going to put the moisture sensor to the middle. And just lightly tighten the screw. Continue on. So basically what the software is doing is it will always move one stepper at a time. And once the stepper is in position, it will power down said stepper so we don't have too much power consumption. And it also kind of makes sure that this thing isn't humming all the time. And we just make sure that we have very little movement when we don't need it. But once the temperature or the humidity changes, all these steppers can move really quickly, and they've got a nice smooth movement. It looks really good. So let's prepare the other two dials. Take the rod, snap it into the groove. Number 2 is done, and here comes number 3. And these just go onto the stepper shaft like this. And we've got analog dials with a digital motor. So this is very similar as in a speedometer in a car or something like that. Three dials. really nice. So let's put the controller board on. We'll take the hot snot blaster. Just put this right in the middle here. I could have made the base a little bit larger, but I don't mind the electronics sticking out that millimeter. Give this a few seconds to get cold. There we go. And we hook up stepper number 1. Stepper number 2. And stepper number 3. We make sure that the common positive lead is always on the left. That's the red one. And now we can try it on, and if we're done we can just fix down the cables on the back so nobody sees them, and we would be done. So let's get some power. So here we have power. Now let's see what happens when we hook this up. Oh, this one here's stuck, it seems. So we got some movement. Let's reset this again. What we need to do is we need to make sure that everything is centered, or this won't move. Like here. So all of them need to go to 0. This one here is not moving correctly. And this one here is too far. But apparently it's moving. It's about 20 degrees C down here. 30%. That appears to be a bit not enough. So let's just get a screwdriver. Sorry for that. So we'll start with the barometer. I should go down to 0, then go down to up to 50%. And if it does that, then it's good. I'll do the same with the moisture sensor. I keep saying moisture, it's humidity, isn't it? Try that one and reset. It zeros to 0 and it should go up to 50%, and then start moving. Same thing with the thermometer. It resets to 0 and it moves to about 50%. Let's give it another millimeter. Tighten it down. Last test. This looks promising. So it looks pretty nice. It's actually pretty beautiful. It's very simple to make, as you can see, because it's just these few parts. I'm going to take care of the loose wires, but apart from that, it's done. All I have to do is find a nice spot for it and use it. So let's fix this down without burning ourselves. When I removed the power regulator, I left the smoothing capacitors on for a reason. The steppers, of course, they do have some induction, and we want to make sure that we don't have any of the voltage spikes coming from the steppers going back to the computer or to the USB power supply, because well, it wouldn't like us for doing that. Okay, that appears to be good. Let's do the same thing over here. So here we go. So let's try to hold this down without burning ourselves. This might take a while. It's actually one of my superpowers, putting my fingers into hot glue when it's still really hot. I don't know, I do that every time. So, all the stepper wires are tucked away. Nice, not clean, but okay for now. The front looks pretty cool. I'm really happy with the simple design. Making these pictograms and getting these numbers on here were quite a lot of work, but I think it paid off. It's a nice little thing. It's very easy to make. Most of the stuff is readily available. This controller board, for example, is on EasyEDA with my username, and these are just two ULN 2003s, one Arduino Nano, and the BME 280 module on the I2C bus, and that's it. So small project, very easy to make, but very impressive. So that's it for now. Thank you very much for watching, and bye.